Okay, Assalamualaikum and a good day. Before we start our presentation, let me introduce myself and our team members. Okay, first, my name is Faris Aiman bin Mohamad and my ID number is TB19021.
My name is Omar bin Ibrahim. My ID number is TB19030.
My name is Affrina Sahira Binti Azham, TB19044.
My name is Siti Asilah Aimi Binti Mohamad Norza'in, and my ID number is TB19002.
We are group 13 and we want to present our mini project on Amplitude Modulation AM transmitter.
I will present about introduction, understanding the problem and the block diagram. First of all, I will tell more about the AM modulation. As we know, AM modulation is a technique that makes use of the amplitude variation in the relative amplitude of the carrier frequency. Next, AM modulation is a sideband on the both side full carrier refer to a signal transmission that include a carrier as well as two sideband. Last, to generate a modulated signal, the amplitude modulation is a combination of the modulation signal and the carrier signal. So for our group, we choose the informational signal 4.5 kilohertz. Next is the understanding the problem. This is the advantages of the AM modulation, which is both is inexpensive and it's very simple to implement. Next, AM modulation is the carrier signal amplitude is proportional to the input modulating signal. It's very simple to assemble and it may be demodulated using a circuit with a fewer components. AM is a low cost, low quality modulation which is employed in a commercial retransmission, which is convey data over a radio carrier wave. AM modulation is the purpose to transform a low frequency to a higher frequency signal using the carrier. Slide is block diagram of AM transmitter. As we can see, use the information signal, power amplifier, oscillator, AM modulator, filter, and the output modulated signal.
For my part, I will present about the description of design step. Okay, it have 4 parts for our design of AM transmitter. Okay, for the first is coil pitch oscillator, and the second is power amplifier, and the third is AM modulator, and the last part is a filter. Okay, next I will explain about the reasoning for the design step. Okay, for the coil pitch oscillator, it used to produce the carrier frequency of 4.5 MHz as it can generate at high frequency. This oscillator is a tuned oscillator and the LC tank circuit consists of capacitor and inductor. Okay, from the coil pitch oscillator equation and this information, we can obtain the value of the inductance which is 0.17 micro. Okay, the next is power amplifier. It is used to increase and produce a greater amplitude signal at the output of waveform, and it also to increase the output power of a transmitter to transmit the signals in a long distance. The value of gain that we obtain from this equation is 2. And the next part is a AM modulator. It is used to mix the informational signal with the carrier signal, and the informational signal modulate the carrier by changing its amplitude to transmit the data to the receiver. And the last part is the filter. The bandpass filter is constructed to allow signals between two specific frequencies to pass through the AM modulator. When oscillator generate the sine wave frequency, there will be some undesired frequency that produce, and this filter will be remove the unwanted frequency. Okay, after that, this is our AM transmission circuit design. So I will show the result of output waveform. Okay. The value frequency of carrier and modulated signal that we get is 4.53 MHz, and the informational signal frequency that we get is 4.5 kHz.
I would like to explain about the implementation with commercial component. So basically our circuit have many parts of component. Firstly, we use VCC 12 volt. We use two. The reason we use the VCC because to supply the power to the circuit. The next we use 8 capacitor to store the electric energy. Then we use resistor with 11 value of the resistor to control the flow of current in the circuit. Next, we use conductor to prevent the sudden change in the current use. Then we used to amplify the voltage by using the operational amplifier. Next, we amplify the current that will allow the BTE are used as an amplifier by using the bipolar NPN transistor. And bipolar NPN transistor, we have two types. First, 150C02MHTL and 2N222A. And we use function generator to produce various pattern of voltage. Lastly, we use variable inductor to control the inductance.
For the discussion, the modulated frequency that we got in the simulation is 4.53 megahertz, which is almost the same with the frequency carrier. Next is the modulated waveform demonstrate, and the modulation index is less than 1. And we got 0.358. Then for the complete circuit simulation, the value of calculated and simulation is different, which is the calculated value we got 0.17 microhenry, while the simulation value that we use in the simulation circuit is 0.15 micro. For the improvement, we must develop a better circuit and experiments with several types of oscillators such as Hartley oscillator and build more amplifier circuit and filters. Secondly, amplifier should be installed to achieve modulating voltage equal to carrier voltage, which is necessitates more exact mathematical operation in order to obtain a better value in circuit design. For the conclusion, we're able to gain new knowledge about the double sideband full carrier. We learn about how to build an oscillator such as filter and AM modulator, as well as to combine them into a single circuit. Lastly, the fact that the output waveform is not a perfect envelope shape that is being modulated by this simulation that we got, at least the output of this AM transmitter is successfully obtained and viewed. That's all from me. Thank you.